Good morning, students. Good morning to all of you. So today we are going to know about the construction of an ellipse. This is class 6. So this is very important topic. Okay, listen carefully. Construction of an ellipse. Construction of an ellipse. So if you want to construct an ellipse, so we have 5 methods. They are eccentricity method or focus directrix method. First method. And second one, arcs of circle method. Third one, oblong method. Fourth one, a parallelogram method. Fifth one, concentric circle method. So these are the 5 methods generally we have for the constructing an ellipse. Okay, if you want to construct an ellipse, so we have 5 methods, but our syllabus point of view, we have only one method, that is general method. So this is called general method, eccentricity method or focus directrix method or general method. So whatever it is, once again listen. So in our according to our syllabus point of view, we have only one method, that is general method or eccentricity method or focus directrix method. So let us see the first method, that is eccentricity method or focus directrix method. So problem will be like this. See here, draw an ellipse by using eccentricity method or general method or focus directrix method when the distance of focus point from the directrix line is 50 mm and eccentricity is 2/3. And also draw the tangent and normal line at any point on the ellipse curve. Once again listen problem. So we have a problem for ellipse. Listen carefully. Draw an ellipse by using eccentricity method. Which method we have to use? Eccentricity method or general method or focus directrix method. So we have to draw an ellipse. The given method is eccentricity method when the distance of focus point from the directrix line is 50 mm. Distance of the focus point is 50 mm from the directrix line, and eccentricity value is given, that is how much? 2/3. So eccentricity value is given, that is 2/3. So here the question is what? We have to draw an ellipse and also draw tangent and normal line at any point on the ellipse curve. So this is our question. So what is the given data? So given data, so focus point distance is given. Focus point distance is given, that is how much? 50 mm. So focus point distance is given, that is 50 mm from directrix line. Focus point distance is given, that is 50 mm from the directrix line. And also if you observe this problem, eccentricity value also given, that is how much? 2/3. So eccentricity value, that is small e is equal to 2/3. So this is the given data. So according to this given data, how can we construct an ellipse? So answer part will be like this. So after constructing an ellipse by using focus directrix method, the final answer will be like this. This is red color shape is called an ellipse shape, elliptical shape. This is the final answer. So after constructing an ellipse by using focus directrix method, this is an answer. So let us see, so how to draw this answer part step by step. Okay, let us see construction procedure for this. Construction procedure for an ellipse by using focus directrix method. So first we have to draw the directrix line. First we have to draw any vertical line, that is DD, as a vertex, as a directrix. Once again listen, first point, draw any vertical line DD as a directrix line. See here, if you observe this figure, so here the AB is called directrix line. AB is called directrix line. Line C is called the line CF. This line is called axis line. AB is called directrix line. So CV line is called axis line. Okay. So first we have to draw the any vertical line. This is a vertical line. AB is nothing but vertical line. So first we have to draw the any vertical line as a directrix line. As a directrix line. Next, second point, at any point C on the directrix line, draw the axis line which is perpendicular to directrix line. Which is perpendicular to directrix line. So see, once again, see here in this problem. So here first we need to draw the directrix line, any vertical line as a directrix line. So mark the point C on the directrix line. Okay, this is a point C. From that point C, draw a horizontal line. This is our axis line. So this axis line should be perpendicular to your directrix line. Okay, so these are the 2 points. Next, third point, mark the focus point on the axis line such that CF is equal to 50 mm. Mark the focus point on the axis line. We have to mark the focus point on the axis line such that CF is equal to how much? Focus point distance is given from the directrix line, that is 50 mm. Focus point distance is given, that is 50 mm from the directrix line. Okay, so we have to mark the focus point. See here in this problem, so this is our directrix line, this is a point C. From the C point we have to mark the focus point at a distance 50 mm. So this is F, 50 mm focus point. The focus point should be at 50 mm distance from the directrix line. So that is the third point. And fourth point is what? Divide the CF into 5 equal parts. We have to divide a CF into 5 equal parts. Why? Because sum of numerator and denominator of eccentricity value is what? 5. So eccentricity value is given, that is 2 by 3. Eccentricity value is given, that is 2 by 3. So 2 by 3. The sum of numerator and denominator of eccentricity value is how much? 5. That's why we have to divide the CF into 5 equal parts. Once again, see here. See, this is CF. This CF we have to divide this CF into 5 equal parts. So from here to this 1 point, second point, third point, fourth point, and fifth point. So we need to divide the CF into 5 equal parts. So why we have to divide the CF into 5 equal parts? So eccentricity value is given 2 by 3. So sum of the numerator and denominator of the eccentricity value is 5. So that's why we have to divide the CF into 5 equal parts. I hope you understand. So next let us see fifth point. So mark the vertex point at point 3. Mark the vertex point at point 3. So fourth point, in the fourth point, CF into divide the CF into 5 equal parts. And fifth point is what? Mark the vertex point at point 3. See. So this is a vertex point. V is nothing but vertex point. We have to mark the vertex point at point 3. So why? Because eccentricity value is given how much? 2 by 3. So 2 means so numerator value. So we have to count from the focus point. From here, this is 0, 1 and 2. Okay. Eccentricity value is 2 is equal to how much? 2 by 3. So denominator is 3. So denominator 3 is nothing but we have to calculate from the directrix line. So this is 0, 1, 2, 3. So these 2 points where these 2 points meet, that is our vertex point. So how can we define vertex point? We can define vertex point where the conic cuts its axis, where the point where the conic cuts its axis. The point where the conic cuts its axis is called vertex point. Okay. So this is a vertex point. So where we have to mark the vertex point? At point 3. So from this is 0, 1, 2, this is 3. At point 3 we have to mark the vertex point V. Okay. This is our fifth point. Next, sixth point. What is the sixth point? From the vertex point V, draw the perpendicular line VB such that VB should be equal to VF. So from the vertex point, we need to draw the perpendicular line VB such that VB should be equal to VF. Once again, see here. So from the vertex point, this is a vertex point. From the vertex point, we have to draw the line VB. So this is not E point, this is B point. So consider this point as E. So from point V, draw the line VB such that VB should be equal to this distance. VB should be equal to V. This is point B. So VB should be equal to VF. What is the VF distance? 2 cm. So this one also 2 cm. Okay. Once again listen. From the vertex point, we draw the perpendicular line VB such that VB is equal to VF and join CB and extend it. Join CB and extend it. See here, join C, and this is considered this point as B. So here point instead of E, here we have B point. Join C and B and extend it like this. Okay, that is the sixth point. And seventh point, from the vertex point, divide the axis line into any number of equal parts, say 12 or 13. From the vertex point, see here. So this is a vertex point. From the vertex point, we have to mark the equal divisions, any number of equal divisions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like so on. Okay. So from the vertex point, we have to mark the equal division points on the axis line. That is the seventh point. Okay, this is the seventh point. And eighth point. Draw the perpendicular lines through the points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to draw the perpendicular lines from those points. See here, if you observe this figure, from these points, from 1, 2, 3, 4, 5, 6. So we have to draw the vertical lines. This is vertical line. This is vertical line. This is another vertical line. This is vertical line through the point 5. This is vertical line through the 6 line. Okay. So we need to draw the vertical lines from point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So ninth point. These lines meet the CB line at 1 dash, 2 dash, and so on 12 dash. So now 10th point, F as center, 1 dash as radius, draw and 2 arcs on both sides of the axis line. So these points intersect at P1 and P1 dash. See here, take 1 dash as a radius, 1 dash 1 as a radius, F is a center point, draw an arc. This is an arc on both sides of the axis line. So repeat this procedure for all points. So you will get the P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12. So if you draw a smooth curve through these points, you will get the elliptical shape. So I will explain this diagram by using drafter. So listen carefully. Okay students, shall we start the construction of an ellipse by using focus directrix method or eccentricity method or general method, whatever it is. So first, so according to procedure, first, what is the first point? First we need to draw any vertical line as a directrix line. So that is the first point. First draw a vertical line. So after that, on the directrix line, this is our directrix line. AB is nothing but directrix line. On this directrix line, mark a point C at anywhere on the line. So we can mark here, we can mark here, wherever it is. Okay. So mark a point C on the directrix line. Okay. So from that C point, draw a horizontal line. Draw a horizontal line. So this is our axis line. From point C, mark from the point C, draw a axis line. So this axis line should be perpendicular to your directrix line. This axis line should be perpendicular to directrix line, AB line. Okay. Third point. So what is the third point? See here, if you observe the construction procedure, see here, this is a construction procedure. If you observe this construction procedure, first, what is the first point? Draw any vertical line at DD as a directrix line. So mark a point C. From that point C, draw a line, axis line, which is perpendicular to directrix line. At any point C on the directrix line, draw axis line which is perpendicular to directrix line. So next, third point, mark the focus point on the axis line such that CF is equal to 50 mm. So we have to mark the focus point. See here, this is our axis line. This is our axis line. So on this axis line, mark a focus point. Mark a focus point which is at a distance of 50 mm from the directrix line. So this is our directrix line. So this is our focus point. So mark a focus point. So at a distance of 50 mm from the directrix line. This is the third point. And fourth point is what? Divide the CF into 5 equal parts. Why? Because sum of numerator and denominator of eccentricity value is how much? 2 by 3. 2 plus 3 is nothing but 5. So that's why we need to divide CF into 5 equal parts. So this is our fourth point. See here, we have to divide the CF into 5 equal parts. So this is point 1, point 2. The total distance of the CF is how much? 5 centimeter. So how can we divide this 5 centimeter into 5 equal parts? Means every 1 centimeter point. 1, 2, 3, 4, 5. Okay. So 5 equal parts. Divide the CF into 5 equal parts. This is our fourth point. So next fifth point. What is the fifth point? Mark the vertex point at point 3. Mark the vertex point at point 3. Okay, we have to mark the vertex point. See, so where we have to mark the vertex point? So this is point 1, point 2, point 3. Okay, so at point 3 we have to mark the vertex point. So at this particular position. See here, so why we mark the vertex point at point 3 only? Means, so eccentricity value is given, that is 2 by 3. Eccentricity value is given, that is 2 by 3. So here 2 is nothing but what? 2 is nothing but numerator. So we have to calculate that value from the focus point. So from here, this is 0, 1, 2. Okay, 2 points. And here the 3 is the denominator. So we have to calculate this denominator 3 from the directrix line, from the C point. This is 0, 1, 2, 3. So where these 2 points met, so that is our vertex point. So that's why we have to mark the vertex point at point 3. So this is a vertex point. Next, next point, what? From the vertex point, sixth point. From the vertex point, we draw perpendicular line VB such that VB is equal to VF. So from the vertex line, see here. So from the vertex point, we need to draw a line VB. So VB, this is VB, this is not point E. So consider this point E as B. So from the vertex point, we draw a VB. So this VB should be equal to VF. What is the VF distance? 2 centimeter. From here to 1 centimeter, from here to here 1 centimeter, 2 centimeter. So VF is equal to 2 centimeter means VE also 2 centimeters. Okay, from the vertex point we draw a vertical line. This is vertical line VP. Okay, so VB should be equal to VF. VB should be equal to VF. Next, so join C and E. Join C and B. This is point B. So join C and B and extend it like this. So we need to join these 2 points, C and B point, and extend it like this. Okay. So after that, from the vertex point, see 7th point, from the vertex point, divide the axis line into any number of equal parts, say 12 or 13 as your wish. Okay, see here. So from the vertex point, this is the vertex point. So from the vertex point, so we have to divide this axis line into any number of equal parts, say 12 or 13. So from the vertex point, so mark from the vertex point, so mark a point for every 1 centimeter. See here, from to vertex point, this is 1 centimeter, next 1 centimeter, 1, this is 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13 like this. Okay, this is 1 and 2, this one 3, 4, 5, 6 and so on, 12 point. So here 1 dash, 2 dash, 3 dash, 4 dash up to 12 dash. So from these points 1, 2, 3, 4 and so on, 12, 13. So we have to draw the perpendicular lines. These are all perpendicular lines. So these are all perpendicular lines. Next point, eighth point. Next, eighth point, what is that? Draw the perpendicular line through the points 1, 2, 3, 4 and so on 12. So that is completed. So these line meet the CB line at 1 dash, 2 dash, 3 dash and so on 12 dash. This is also completed. Now F as a center, 1 dash as a radius. Draw 2 arcs on both sides of the axis line. So this is very, very important. See here. So here 1 dash. So this is 1 dash. This is 1 and 1 dash. Take 1 dash as a radius. Take 1 dash as a radius. F is the center point. So F is the center point. Draw 2 arcs on both sides of the axis line. So here and here. So above the axis line, below the axis line. Once again, see. See here. This is a 1 dash as a radius. F is the center point. So this is an arc. Draw an arc both sides of the axis line like this. And 2 dash as a radius. Draw an arc both sides of the axis line. Similarly, 3 dash as a radius. F is the center with the help of compass. So 3 dash as a radius. F is the center point. Draw an arc both sides of the axis line. And similarly, 4 dash. F is the center. So draw an arc both sides of the axis line. And similarly, 5, 6, 7, 8, 9, 10, 11, 12. So we will get the arcs like this. Okay. So this is a P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and this one is P12. And similarly P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, P6 dash, P7, P8, P9, P10, P11 and P12 dash. So these are the arcs. So from these points, so start from the vertex point. From here, draw a smooth curve. Draw a smooth closed curve. See here, this is our ellipse. So from these points, P1, P2, P3, P4 and so on, P12, P1 dash, P2 dash, P3 dash and so on, P12 dash. So if we draw a smooth closed curve from these points, so we can get the elliptical shape. This is a ellipse. This is our required ellipse. The red color shape is the answer part. So remaining all lines should be thin lines. We have to use 2H pencil only. So for answer part, this is a ellipse shape. Red color line is ellipse shape. So we have to draw this elliptical shape by using HB pencil. So this is a answer. I hope you understand. Thank you. Thank you so much. Sorry. So for this we have to draw the tangent and normal line. For this we have to draw the tangent and normal line. So mark a point on the ellipse curve at anywhere on the ellipse. So I am marking here at this particular point. Mark a point on the ellipse curve. So from that point join this point and focus point. Join this point and focus point. So from this is point P. So PF, for the line PF, draw one perpendicular line. This is our perpendicular line. So if this perpendicular line meet your tangent directrix line at particular point, that is T. So from the T point, join T point and starting point. So the green color line will be your tangent. So for that green color line, draw on perpendicular line. So that is your normal line. So this is so normal line and tangent should be perpendicular to each other. Okay. So I hope you understand. Thank you. Thank you so much.